This is Mr. Precella working with this college algebra class today. And we've already been discussing graphing circles, ellipses, and hyperbolas. And now we're going to look at something called a function. And it'll be clear why we did circles, ellipses, hyperbolas before functions once we're midway through the discussion of functions, okay? But first of all, what is a function? A function, and this is, I think, right now assignment number 9 for us this semester. A function is a rule which assigns to each x value one and only one, or else you might say exactly one y value. So each x value is being assigned exactly one, or one and only one y value. Remember years ago, this is one of the things that stood out in my head in high school algebra. At the time I had no idea I'd eventually major in math or anything like that. The teacher talking about one and only one. I thought, that is stupid. One is one. So why does she say one and only one y value? And it wasn't until later that it dawned on me. If someone asks, you're at Whataburger with a friend and they're short $1 and they ask, do you have $1? And you have $20 in your wallet? Well, the answer to that is, well, yes, you have $1 and you have 19 more dollars also. If the person had asked, do you have exactly $1? Well, then if you have $20, you'd have to say no. If someone asks, do you have $1 and you have more than $1, the answer has to be yes. So how do we say each x value can only be assigned one and only one, or exactly one? That means it can't be assigned two y values. So now our first example, by the way, I've used my little scissors and cut our homework problems up into little strips. My brother was laughing at me. I was like, when I first started doing these, I'd have my scissors up here cutting it as I went, but I've gotten so much more sophisticated now. I cut the strips before class, okay? And that is sort of a joke, but still, let's look at this little diagram. Can y'all see it, or do I need to zoom it in? It says, determine whether this relation is a function. They're using the word relation the way I use the word rule. And give the domain and range. Well, we've already introduced that phrase, domain and range. Domain refers to the x values, and range, those are the y values. So let's look at this. Do y'all agree? This looks like the set of x's that are being assigned y. So over here's the x values, and over here's the y values. Ooh. Is each x value being assigned exactly one y value? Like the number 9. How many different y values is it being assigned? Only one. What about the number 11? It has only one y value. What about the number 3? Just one. So is this a function? What are we going to say? Yes, it's a function. Each x value is getting only one y value. Sometimes students will say, well, let me see one that's not, what would, if it were a function, what would it look like? If there were a line going from this 3 also to the number 17, if we had a line going from 3 to 4 and also 17, if 3 were being assigned the y value of 4 and the y value of 17, that would not be a function. So here's one that's not a function. I'm going to draw it right here. Oh, let me use a darker. Oh, wow. Today the orange seems to be showing. If we had that 9, 11, 3, and over here, 4, 17, 9 is being assigned the y value 4. 11 is being assigned the y value 17. If 3 were being assigned, if any one of these, I'm just picking on 3. If 3 were being assigned 2 different y values, then there's one that's not a function. Where's one that is a function? Well, right below it. Let me move this up a little. And then it says, okay, find the domain and the range. Well, to type the domain, you're just going to write in or type in the x values. Use a comma to separate them. So you type 9, comma 11, comma 3. Probably it's best don't hit spaces. Okay. And then the y values are 4 and 17. Okay. So a function is a rule. It assigns each x value exactly 1, or 1 and only 1 y value. If you have an x value being assigned 2 different y values, then this thing is not a function. Now, when we talk about x's and y's, that brings what to mind? Notice I'm not saying a and b, I'm saying x and y. Does that bring to mind ordered pairs, x, y? So another way we could write functions is as ordered pairs, like this one right here. Let's take this little rule, and I'm going to write using ordered pairs. So I'm going to take this function right here and write it using ordered pairs. It would look like this. 9, comma 4. 11, comma 17. 3, comma 4. Okay. This is the one that is a function. Okay? This one is a function. What if we did the same thing with this one up here? Write out the ordered pairs that would be generated from that. It would be 9, comma 4. It's going to be the same thing we wrote right here, except there's going to be one more ordered pair, isn't there? 11, comma 17. 3, comma 4. And 3, comma 17. Now that one we said is not a function. Oh, is that orange still showing? Yeah. Ooh. Could y'all figure out a way? Now, take this one's a function. Excuse me. This one's a function. This one isn't. Could y'all figure out a way to look at a set of ordered pairs and determine this one's not a function and this one is? What makes this orange one not a function? Yes. 2 ordered pairs with the same x coordinates. Here's another way of defining a function. A function, see, there's 2 ways of defining functions. I asked my brother before class, how are you going to define it first? Ordered pairs or rule? And he said, I think I'm going to do ordered pairs. And I said, I'm going to do it as a rule then. A function is a set of ordered pairs in which no x values are repeated. In other words, repeated x values not a function. When you're looking at at ordered pairs, if you have some repeated x's, like right here, the number 3 was repeated, then it's not a function. And that's another way of defining function. look at the ordered pairs and see are any x values repeated. Is it okay for y values to be repeated? Yeah, the y values can be repeated. The x values cannot. So with that in mind, problem number 2, okay, it says determine the domain and range, tell whether or not it's a function. Oh, they want us to punch in the domain and range first. No, I should have already mentioned this, but it didn't happen here on this. You don't repeat anything. If there's any repeated x's or y's, you don't repeat them when you list them out for the domain. So like right here, the domain would be 9, comma, and you're just going to type these numbers in the box. 21, 33, 9 I've already listed once, so don't list it again, 60, and if you list the same thing twice, I've done that in class in previous semesters just to see, is it smart enough to say, hey, don't list the same thing twice, or is it going to say just wrong? And it's smart enough. It'll say, oh, the numbers you've entered are right, but you shouldn't be repeating one of the numbers. So now the range, what am I going to type in? 5, comma, -6. I'm not going to repeat the 5, and 8. Is this thing a function? No. And right now what Pearson's working on is, once you answer that question, it'll say why. And there's all these little paragraphs written out that you've got to muddle through. So that'll be the next generation of my math. They're already doing that in things like statistics. Oh wow, and those statistics problems. I'm teaching an online statistics course. And I'm like, isn't there a way to cut off this GHI, you know, when you're doing a problem and it goes part A, B, C, D, E, F, G, H, I. That's just getting way too long, and that's what they're doing with this algebra. They're going to be there, okay, why or why not? Or once you've answered, what do y'all say, no? No? Wait, yes, no, or no?
No. No, because
just no, right? Oh, okay. And why is it? Because right here there's some repeated x values. If there's repeated x's, not a function. Now, earlier we've graphed circles and ellipses and hyperbolas. Let me just now ask a question. What about a circle? Is a circle a function? And if so, why didn't we define it before we graphed circles? Well, I'm just going to draw a graph of a circle, and we'll look at that to decide if a circle is a function. Let's suppose I'm going to try to draw a circle centered at 0, 0 with a radius of 2. So I'm going to pretend I have a compass up here. Oh, it's going to look more like an ellipse. My scale is a little off. Okay, we have a circle. This is a circle centered at 0, 0 with a radius of 2. Not that the radius really matters, but if you think about all the different little ordered pairs on here, if you were going to start listing them out, like this ordered pair would be the point right 2 up 0 right here. Like this ordered pair right here, what would it be? If it's a circle of radius 2, it would be 0, comma 2. If you were listing out, let's just say these 4 points right here, the ones I'm pointing at. Are there any repeated x values? Because if there's any repeated x values, it's not a function. Could y'all tell me? I'm going to give you a hint. There's another point on here that has 0 as an x value. Which one?
0, -2.
Right here, 0, -2. So are circles functions? No. Now, why did I choose to pick on that x-axis? Well, excuse me, on this y-axis. Anywhere that a vertical line intersects a graph twice? Here are 2 points, like this one here, this is a 1 there. This orange point here and here both have what number as x value? 1. So there's 1s that are repeated, 0s that are repeated. In general, circles are not functions. What about ellipses? If we flattened this sum and had an ellipse, would it be a function? No. Hyperbolas? No. There's something called the vertical line test. Here's how you can just look at a graph and decide, is it a function? Vertical line test. If a vertical line intersects a graph more than once, the graph is not a function. This circle here. You can draw vertical lines and they intersect it more than once. Like the y-axis, heck, the y-axis intersects it more than once. So it's not a function. What about something like a slanted line? Would a slanted line be a function? Let's answer that question. Is a slanted line a function? Now, to do that, let's just draw a slanted line. Here's my xy axis. And I'm just going to draw a slanted line there. If you started drawing, notice it only intersects the y-axis once. What about if you drew other vertical lines? With a slanted line, would a vertical line ever intersect it more than once? No. So is this a function? Yes. Where's my little snips of paper? Done that one. Done that one. Oh, well. Number 3 says decide whether or not the relation defined by the graph to the right defines a function and give the domain and range. Well, they want to put a lot of words in these instructions. Okay, is this graph a function? And then we'll discuss the domain and range. What the heck that, how you find that by looking at the graph. Well, it's a slanted line. Any slanted line is going to be a function. So, yes. Now, when it asks, and this is the first time we've found domain and range is looking at a graph. So, this graph means, or these arrows mean you continue drawing the graph. It's going up and down. It's also moving left and right. Is it, imagine if we continue this xy axis all the way to negative infinity and positive infinity over here. Will it keep going and going to the left and to the right and eventually reach way over here at negative infinity and way over here at positive infinity? It's going to keep going left and right? Yeah. The domain here, like right, you can keep drawing this out and you can see easily, okay, it's stretching from negative 10 to positive 10. The question is, if you keep drawing it out, will it eventually be over at negative 1 million and positive 1 million? Yes. The domain of a slanted line is always going to be all real numbers. And we're going to write all real numbers in that interval notation, parentheses, negative infinity, comma infinity. When you type this in, don't put any spaces. That's how we'll be writing interval or all real numbers. So it spans the whole x-axis. Right here, if we keep drawing this up right here, it'll sure go from negative 10 to positive 10. Does it keep going down and up? Having seen the domain, could y'all tell me what I'm trying to say the range is going to be? Would it eventually get way down here at negative at negative infinity? We keep drawing this, and way up here, you can't see it, at positive infinity. Yeah, I claim the range is also going to be negative infinity to positive infinity. For any slanted line, the domain and range is all real numbers. Why is that? Because a slanted line keeps going to the left, it keeps going to the right, it's also going up and down. The next one will help you get the hang of this domain and range better. Any questions on that one? Very silent. The next one is not a slanted line. It's a different looking graph. Okay, asks. Same instructions. Okay, is this graph a function? No. Well, right off you can see the vertical, the y-axis intersects it more than once. All you need is one vertical line. But, I don't know if y'all can y'all see little grid marks up there? There's a lot of vertical lines, aren't they, that are intersecting it more than once. So does the graph define a relation? Excuse me. Does the graph relation define a function? No. Now we're going to look at the domain and range here. Over here on this one, if you keep drawing out the arrows, it stretches all the way from way over here to over here. Not the same things happening here. If you keep drawing this out, it's going to keep going not to the left, it keeps going to the right and up, and also to the right and down. So for the domain, do I need to zoom that in? It's not going to be negative infinity to infinity. What's the smallest x value that you have? Negative 5? Oh, wow, y'all have good vision. Let's see. There. Negative 5, that's where that's the smallest x value. The graph starts here and then starts moving to the right. So the domain, it's going to be from 5 on to infinity.
Is it negative 5?
Negative 5, sorry. You always put parentheses by infinity symbols, but what about at this negative 5? Is there do we want to include negative 5? Yeah, I heard someone say use a bracket. You're including negative 5 there. So what is this saying? All of the x values are from negative 5 and bigger, including negative 5. Now, what about the range? Well, these little arrows here, it's saying it's going to the right, and it's also going up and down slowly, but it's still going up and down. Will it eventually span from negative 10 to positive 10? Yeah, what about negative 1 million to positive 1 million? So on this one, the range is going to be negative infinity, comma, infinity. Why that? Because it's going up and down. And magnify that so you can see the whole problem. Any questions on this? This is y'all's number 4. So functions, we've seen them, they could be written just as a little rule, or they can be written as ordered pairs, or you might see graphs. So another way you might see functions written is as equations, functions, can also be, maybe I should say, are usually written as equations involving x and y the letter y can be written using function notation, which looks like this: f parentheses x. You don't really read it as f parentheses x. You're going to read this as f of x or a function of x. Don't panic. It isn't going to start getting any harder than, I'll tell you when it starts getting harder. Here's number 5. So we have an equation. Remember, equations have equal signs. But instead of the letter y being used, there's this f parentheses x, the function notation. And so it says f of x equals negative 10x plus 5. Find f of 1/2. Oh, that candy was so good the other day. You really could. It's amazing. It's soft, but it doesn't stick or anything. Okay, I mean to your teeth. Okay, I'm giving y'all a moment to catch up. Oh, it was really good. As a child, there used to be this commercial that we would mock the woman on. She would say, "And it doesn't stick to my dental work." And we'd say that, not knowing what the heck they were really talking about. "And it doesn't stick to my dental work." And now I can say that, not that I have any dental work, but it doesn't stick to my dental work, okay? But as a child, I didn't know what the heck the woman was saying that for. So we have f of x equals negative 10x plus 5. Here's the rule that's going to assign every x value exactly one y value. Find f of 1/2. The number inside the parentheses, that's the x. So to find the corresponding y, what do you think I'm trying to say we're going to do with that x? Yeah, okay, plug it in there. Plug the 1/2 in for x. So negative 10 times 1/2 plus 5. Let's see, the negative 10 times 1/2, is that just going to be a negative 5? No, y'all agree with that? Negative 5 plus 5. Is this going to give me 0? Yeah. So the number 1/2 is being assigned the y value 0. Remember, with a function, every x value gets exactly 1 or 1 and only 1 y value. So you'll type a 0 in there. Now, this is a pretty short problem. You just take whatever number's in the parentheses and plug it in for x. Maybe this is one of those times there should be a part A, B, C, D. Suppose it had said find f of, I'm making up a few more. If it said find f of 7, instead of giving you the 1/2, let's find f of 7. So it's saying plug a 7 in for x. So we'd have negative 10. Oh, up here I use the parentheses for times. My habit is to use the little star. Negative 10 times 7 plus 5. What's that going to be? A negative 70 plus 5. What's the y value that's being assigned to this? Negative 65. With the function notation, whatever's inside the parentheses, you plug it in for x. Okay, with the function notation, whatever's in the parentheses, you plug in for x. Just to make sure you get the hang of it, I'll do one more. How about f of, let's use a messy number, negative 9. Whatever's in the parentheses, you plug in for x. So you come up here in place of the x, I'm going to put a negative 9. So I have negative 10 times a negative 9 plus 5. 95? Yeah, it's going to be a positive 90 plus 5. Did y'all hear 95? That's right. Okay. And again, I'm just making these numbers up here, okay? Your problem, more than likely, it's going to still have the 1/2 there, but it's going to change the number 10. And I think if I'm recalling it correctly, it's rigged where this first number here will be an even number. So you can do it easily, okay? I've never seen it come out where it says, okay, find f of 3/7 or something like that. And usually it's rigged to work out pretty nicely. So whatever's inside the parentheses, you plug in for x. Having said that, let's do number 6. Oh, you know what? Let me get another sheet. Here's number 6. Again, I've just printed out the homework and cut it into little strips. It makes it easier to show it. Y'all still have that good vision, or do I need to zoom in? I'll say what I just said. Whatever's in the parentheses, you plug it in for x. Having said that, let's see, f of x is negative 3x plus 4. Find and simplify f of n. Well, there's not much to do to simplify it. Y'all want to call out the answer? I'll say the sentence again. Whatever's in the parentheses, you plug in for x.
So 3 n, or negative 3 n.
Negative 3 n plus 4. Whatever's in the parentheses, you plug in for x. Some of these problems, I guess maybe you've gotten accustomed to doing those really long problems. This isn't some of them. Okay. Whatever's in the parentheses, you plug in for x. Okay, good. This doesn't record the magnification, so just want to make sure. Let's see, like on number 7, let's do this one. This one's going to take a little bit more effort. Still not going to be really hard. It's just going to take a little more effort than number 6. They can't all be as easy as number 6. Here we're told f of x is negative 4x plus 5. Find and simplify. Now the simplify, there's going to be something you can simplify. F of 3m minus 4. So I'm not having to write down the problems. I think at times I'm going too fast. Y'all caught up? Whatever's in the parentheses, plug in for x. So I'm going to go to the negative 4x plus 5. But instead of that x, I'm going to put the 3m minus 4. Is my invisible orange ink still visible today? Yeah, okay. So in place of that circled orange x, I'm putting the 3m minus 4. So there's a little bit we can do here to simplify it. What would we need to do? Okay, distribute that negative 4. So what are we going to have? A negative 12m plus 16. Now we still have that plus 5, which I guess we can go ahead and write as negative 12m plus 21.
Yes.
Oh, well, you'll type it into that box. Okay. Negative 12m plus 21.
When we type in our answer, do we have to simplify that? Do we have to factor out numbers, do you know?
Oh, I wouldn't.
Okay.
No. Okay. I'm wondering, I mean, with my math lab Pearson's, I've never even thought of factoring out a 3 there or something, but my brother was telling me in a business business calculus class, he had a big expression, and he factored out something to make it look a little easier, and it said wrong, and he had to type in the whole expanded form, and it was a big expression, something much bigger than this. I think he said he was factored out 3e to the 4x plus 9, and I was like, well, first of all, why did you decide? And it did make it look a little easier. It was showing it to me, and I was like, yeah, it said wrong. He had to type in the whole expanded thing, and of course he did it as a video, and then he was like, oh darn, I need to go back and delete that video because I'm gonna have to go in and tell him it won't let you factor it out. You've got to write it. And I was like, oh well, go ahead and leave it and just tell the class. But now, okay, going back to this stuff right here. The first, I just started that function notation. Whatever's in the parentheses, you plug it in, and that gives you the y value. The number in the parentheses is the x. Your answer is the y. X, y. To find f of negative 9. Negative 9 is the x. 95 is the y. I'm watching this and I think, why has it got it all... Having said that, number 8. F equals, and notice it's given a set of ordered pairs. 6, 9, 4, 6, 5, negative 6. Find f of 6. How do we find f of 6 looking at these ordered pairs? Well, you've got to think. The number in the parentheses is what? X or y? X. Your answer is y. What number am I going to type in there? I see several 6's up there. I'll give you a choice. Am I going to put a 9 or a 4? 9. 9. You put the one that has 6 as x. Your answer is the y value 9. Maybe this is one that it wouldn't have hurt to have more than just one little part. Maybe this is one where it'd be good to have a part A, B, C. What if it said, and I'm just making this up now, what if it said, once you find that, find f of 5. What would f of 5 be? Negative 6, the x. What this is saying is, okay, x, the number 5, that x value is being assigned the y value negative 6. And I'll do one more. What do you think I'm about to write? F of, yeah, that's the only other option. F of 4 would be 6, okay. So, the number in the parentheses is x, the answer is y. Here's a problem I remember last semester gave a lot of trouble, and I wasn't expecting that. You know, I sort of have an idea which problems give students a hard time and which ones traditionally don't, but I'm thinking this was the problem last semester that gave the hard time, and I was sort of shocked. I wasn't expecting that. I think in one of my classes, we spent an awful long time on this problem. So let's see. The number in the parentheses is x or y? X. Your answer is y. So the number in here is x. The number you're going to type in is a y. But you've got to look at the graph. Find the point on the graph that has a negative 3 as the x value. Where is negative 3 in x value? There's only one of them. Right here? What's the y value? Right there. I'm using the one, This is the point that has negative 3 as an x value. What's the y value at that point? 0. So you just type a 0. This 0 here has nothing whatsoever to do with this 0 here. Okay? So which point am I? I'm going to circle the ordered pair we're looking at. Oh, I don't think I have a highlighter. If I did, I'd highlight it. Actually, I do have a highlighter. Okay. I'm going to highlight the ordered pair we're looking at. Look at the ordered pair as 0 for its x value. Would that be right here? And what's the y value at that point? 6. So right here at this point, x is 0 and y is 6. Now for the next one, f of 4. Ooh, that one's a little, it's not one of the big dots on here. F of 4, is that right out there? So what's the y value? I think I hear someone saying it. 2. Okay. And finally the last one, f of 6. I'll just stick with yellow. That looks better. F of 6 is 6. There was this problem last semester that, oh wow, the student had all these little rules where this number here was that number, and this number here always equaled that number. And I was like, no. You've got to look at the graph to get these numbers. Okay? Is it clear how I'm getting these? Just looking at those ordered pairs. The number in the parentheses is x. Your answer is y. Any questions? Now, for 10 through 15, I already have those recorded video. Do I keep it like this, or do I stand up and do it off the board on here? What do y'all want me to do? I'll let y'all make that decision. Do I keep recording like this, or do I do it up here? It doesn't matter. But it's so rare. Usually I'm my back to you. I think I'll stick with facing y'all, okay? So, next thing we're going to do, I may as well let you see them. We're going to have functions that are written as equations. We're going to have functions that are written as equations, and the instructions are going to say find the domain of the function. So how do we find the domain? It's pretty easy to find the domain when you're, like problems 1 and 2. Those were pretty easy, find the domain. But how do you find the domain? Oh, it's pretty easy if there's a graph given also. But what if you just have a equation or a formula? Sometimes it will say, okay, how do you find the domain when the function's written like this as a formula? Well, there's a few rules that you need to know. Okay. Finding domains of functions in the form f of x or y equals some ... some equation. Well, this is one of those. They're multiple. Most of them are multiple choice, and unfortunately, when you're doing the homework, you can sort of guess, and you get more than one guess. But on the test, you don't get more than one guess. So try not to just sit there click until you get the answer. what we're going to want to do is avoid, there are two types of errors we get on our calculator, and that's the division by zero, if you have a number over zero, and also there's another type of error we get, it involves a square root, negatives under the square root. So what we want to do is figure out what numbers can we plug in for x. You want to avoid getting a zero in the bottom of a fraction or a negative under a square root. If there's no square roots in the problem, then you don't even have to worry with that. In fact, if there are no fractions and no square roots, like I'm going to do this a little out of order. Number 11. Oh, I'll cover up this. Find the domain of this function. Well, what numbers can we plug in with our calculator? Well, we don't want to get those error warnings about division by zero or square roots of negatives. I think it'll say something like non-real answer, which is what the calculator usually does. Here, if there's no fractions and no square roots, the domain is just all real numbers. So I think everyone's number 11 is going to be like this, where there's no fractions and no square roots. But rather than just thinking, okay, number 11 is all real numbers, you think no fractions, no square roots, all real numbers. Now, what about problems like 10 and 12? Problem 10 says, okay, f of x equals 6 over x plus 4. Believe it or not, we've found the domain of function like this before. I think we've done it twice. Once we were solving rational equations, and then when we were doing cut points. We called them denominator cut points. Every now and then I might have slipped and said domain cut points, because it's the same thing. What's the one number x could never be? Okay, we can't have a zero in that bottom, so x can't be negative 4. So here's my thought process. It's the same thought process I use when finding denominator cut points. The denominator can't be 0, so x can't be negative 4. So we want to know what numbers can x be. In words, you would write it out like this. All real numbers except negative 4. What numbers can you plug in for x? Anything except negative 4. But, of course, it's not written out in words. It's written out using interval notation. And the way you write all real numbers except something. If we were talking about everything except negative 4. We were talking about on the number line, everything except negative 4, but I put an open or closed circle here at negative 4. Open because I don't want to include negative 4. I want everything except negative 4. So which one of these would be that interval notation? Would be negative infinity to negative 4 union negative 4 to infinity. A. So this is just a fancy symbolic way of saying all the numbers except negative 4. During my mathematical lifetime, everything's gone to interval notation, partly because that's the sort of stuff that can be programmed into things like my math lab. Typing out the words, all real numbers except. But when I began my mathematics career, it was before so much computerized stuff, we were always told, if you can write it out in words, write it in words. Don't use symbols if you don't need to, because well, it's going to be hard to type it out and so forth. Number 12, what's the domain? It'd be all real numbers except what? Negative 10 and positive 7. So if this were late 80s, early 90s, our answer would be all real numbers except negative 10 and positive 7. Well, it isn't. It's written in interval notation. And I guess it's pretty easy to guess which one it is because there's only one of them that even mentions negative 10 and positive 7. D. But let's just make sure to say all real numbers except negative 10. You'd go like this, not include negative 10. So there's the negative infinity to negative 10. Then everything in between negative 10 and 7. And then everything to the right of 7. So this is just a fancy way of writing all real numbers except negative 10 and positive 7. Are y'all caught up? Number 13 has a square root, and it's one where you're going to have to type in the answer. It's not, there are two of them, 13 and 15, but you got to type in the answer. It's not multiple choice. Well, with a square root, we don't want a negative under that square root. That's what we've got to try to avoid. So how do we figure out what numbers can we plug in? I guess we could just do a guessing thing. Well, could you plug in a 0? Yeah. That would give you a positive 40. But there's actually a little process you can do, sort of like the cut point method for the square roots. Let's figure out when 40 minus 5x equals 0. Let's figure out when it equals 0. What would y'all do? Would y'all move the 5x over or the 40? If you move the 5x, then at least then you have nothing but positives. If you move the 40, that's fine. You're still going to get the same answer, which is what? Wait. Okay, the 40 over 5 is 8. Now I'm going to do a little cut point thing. Draw a number line. Ooh. These are really bad equal signs there. Okay. Draw a number line, and now let's just test on either side of the number line. What are we testing for? To see which side gives us positive numbers under the square root. That's what we want, not negative. Like if we take numbers smaller than 8, 7, 6, 5, 4, 3, 2, 1, or 0, if we take a number smaller than 8 and plug it in, let's say 0, what are we getting there? Positive or negative?
Positive.
Positive. So that's what we want. We want this stuff here. I'm betting on the other side we'd get negative. Let's see, if I took a number like 9, 10, 11 and plugged it in, wow, this is a nice functional analysis we're doing today. One day I'm going to change these homework names. Instead of saying functions, I'm going to call it functional analysis and all that little graph stuff. Intro to graph theory and stuff. I'm going to really change the names and make this course sound really advanced. Okay?
How are you getting the negative?
If I took a number like 9 or 10 and plug it in.
Okay.
Let's say I test a 10. If I test a 10, I would have, the orange is now invisible. Okay. The 40 minus 5 times 10 is 50. That would be a negative 10 under the square root symbol. Any number to the left of 8 you could use to test. Okay? Now, what about the number 8? If I actually plug an 8 in for x, what's that going to give me?
0.
a 0. And if I were doing it on the board, I'd pull up my calculator. Oh, let me see. It's one of those. This is going to be hard to see. It's going to be a glare, but it records nicely. Let's plug a 0 in for x. Excuse me, plug an 8 in. And let's see, is it going to give me an answer or is it going to give me an error warning? If I plug an 8 in for x, I'd have second square root. Let me see. Oh, that's sort of visible. 40 minus 5 times 8. I'm plugging the 8 in for x to see, is this going to give me an error warning or is it going to give me a number? What do y'all think it's going to do?
Error.
That's it. If I plug it, I hit enter. It's just saying, oh, can y'all see it? 0. It's okay to have a 0 under the square root of under a square root symbol. It's not okay to have a 0 in the bottom of a fraction. But when I plug an 8 in, it gives me a number, so you're going to include this number here. So to type in your interval notation, it's going to be parentheses, negative infinity to 8, now bracket. Is it clear why I'm saying this is going to be a bracket here? You're including the 8 because you're saying if you plug in 8, you get a number on your calculator, not an error. So with these square roots, these are the ones that take the most thought. That's why I think of it as functional analysis. The ones at the square roots, 13 and 14. Mm-hmm.
What if you plug in a different number?
Oh, well, if you plug in a number smaller than 8, you'll get an answer back. If you plug in a number bigger than 8, you'll get a negative, an error warning.
What if you plug in 0?
Okay, if you plug in 0, you'll get a real number. The reason I plugged in 8 is because I've got to figure out between open or closed circle there. Okay? But like over here, that was 0 was the one I plugged in when I tested it here. If you plug a 0 in, I just didn't write it out. You'd have 40 minus 5 times 0 is 0. So we're getting a square root of 40, which it's a decimal number, but it's a real number. No error warning there. 6 point something. Okay? Did I answer? Oh, okay. The reason I'm testing the 8 is because I need to know between open and closed circles. Like over here on number 14, it has this is the most involved. It has 2 things happening. It has a fraction and a square root. There are 2 things we want to avoid. We don't want a negative under that square root symbol. We also don't want a 0 on the bottom. Those are the 2 things we don't want to happen. To get started, take what's under the square root symbol and ask what'll make it 0. Now that's one you can sort of do in your head. 10 would give me a 0 under that square root symbol. Now, either decide between open and closed circle on 10 first, or decide positive and negative first. Which one do y'all want to do? Let's do the positive and negative. Okay, at this point you're looking for the square root, trying to figure out where are we getting positive numbers under that square root symbol. If we took numbers like 9, 8, 7, or 0 and plugged it in here under the square root, what would we be getting if we plugged a 0? Positive or negative? Negative. That will not be part of our domain. You can sort of guess the next one. If this one's negative over here, what's going to be here? Positive. If you plug numbers like 11, 12, 13, 14, that's giving you a positive number. So the answer is going to be the domain. Oh, hey, this one you don't have to type it in, but I'll hide them so you don't see it. It's going to be 10 to infinity, but we've got to decide between bracket or parentheses at the 10.
Should be parentheses,
Okay, it's going to be, if you, let's get my calculator, which you can't see, but for some reason on the YouTube stuff, once it's uploaded, it looks really good. The calculator usually does. Okay, let me see. What if I put it right there and lift? Okay, I'm plugging a 10 in. 1 divided by second square root, 10 minus 10. I'm plugging that 10 in for x. And what's it going to give me? It gives an error. What kind of error? There are two types of errors you'll get. Either division by 0 or non-real. Ooh. Divide by 0. Okay? So do I include the 10? No. So what this is saying is you can put any number bigger than 10 in for x, but not 10. You see there's two of these. B and D look an awful lot alike, but it's going to be B. Okay? If you just want, okay, if there's a square root and no fraction, you're using a bracket. If there's a square root and a fraction, you're using parentheses. Hopefully you can sort of follow the logic why. Again, this is a really advanced functional analysis for this course. Okay? Any questions there? Let's see. Why we're putting parentheses here and brackets up there. The parentheses is saying you can't plug a 10 in. You'd get 1 over 0. The bracket is saying, yeah, you can plug an 8 in because 40 minus 40 is 0. The square root of 0 is 0. Take your calculator and try square root of 0. It'll let you do that. It won't let you do 1 over the square root of 0. And then we end on a sort of a lighter note than those. Number 15 goes back to something like number 12. Number 12 was pretty easy because the denominators were factored and stuff. You can just look at them. The thing that makes this one a little bit more involved is you're going to first have to factor it. How would we factor this? X and X. Okay, so it's going to be a 1 and 8. And I heard a negative on the 8. Mm-hmm. Yeah. Now that it's factored, is it as easy as number 12? Well, yeah, except it's not multiple choice. Okay. So let's see. For this first one, it's going to be all real numbers except what and what? Negative 1 and positive 8. X can't be negative 1. X can't be 8. Not multiple choice, so let me see. Oh, wow. This one, you're going to have to type in all that interval. You want everything except those numbers. Everything except. Are there going to be any brackets in this? Say no? No. Okay, so the interval notation. You have to type it in. Negative infinity, comma, negative 1, parentheses, union, parentheses, negative 1 to 8, parentheses, union, ooh, 8. Can y'all tell my 8's from my infinity? Try to assign multiple choice on as many of these as I can, just so you don't have to type a lot of these in like this. But there's getting fewer and fewer of these multiple choice on my math problems. Okay, it's getting more and more advanced, but you can just type it all in. Okay? So this is one of those assignments. It takes me a long time to say everything, but it doesn't take you a long time to do every problem. I guess number 50, these last few are the longest. But it's certainly not the same as completing the square to get those circles and or doing a whole big cut point problem, okay? So this ends week 6, so try to stay caught up. Okay. So work on some of your homework this weekend.
When is this assignment due? Do you know?
Oh, let me see. It's due 1 week from Monday, which I'm thinking is the March the 9th.
Okay, so it's after assignment 7.
Oh, it better be. If I
I think
don't.
it's a week after, is what I'm saying. I think 7 is like 3 or 2, and then 8 is the following Thursday.
Circles
and then
was
9.
due. Circles is
Right.
due the
It
second.
start
Yes.
going, it's almost like it's every time we meet then. After a test, it seems like. I mean, I did it all. I just-
Oh,
I was
okay.
curious.
Ideally, it's 1 week, but y'all are the ones that are ahead. So it's like, I'm not doing this until Monday in my 8 o'clock, in my Monday class.
Oh, okay.
So it's 1 week from Monday.
Gotcha.
I'll just do this stuff. Oh, shoot. Let me stop recording this.